So I think this is the end of BlinkOn 5 and get the very illustrious spot of being able to take the whole conference here, which is very exciting. And by the power of the magic buttons up here, slides, they magically appear. And so I'm here today to talk about Blink's architecture and our layering and where we want to take the code base. Blink is this really big code base, and recently, as you saw in the keynote, this large marshmallow-like chromium creature crept up on us and sort of like sucked us in. Very painlessly, sort of pillow-like, nobody really noticed. And I'm here to talk about sort of where we're going to go from here. So let's start with now. What does the code base look right now? Here is a pretty diagram of sort of what our code base looks like, very idealized. You can see there's like this web layer at the top, there's this platform at the bottom, we have the WTF library on the side, sort of aptly named, and then there's core and modules. And just as a key, I have these orange lines, which means things are used, and these blue lines, which means things are implemented from. So there's the platform, but it's actually implemented way over there in content. If you've ever had to work on the boundary, you've seen the code on both sides. They're kind of like really far away. We don't have to do two-sided patches anymore, or three-sided patches, which is a big improvement. See, arms up. Who's excited about that? Woo! Yeah! It's awesome. Gone are those days. So it seems really simple, right? Like web uses core. If we go back to this diagram, it's like web uses core, and like we have this API layer, and everything makes sense. But it turns out web doesn't really use core quite like this. It's not nearly that simple. It looks a little bit more like this. So web uses core, and core has this Chrome client impl that's implemented in web, and web implements this frame loader client that's implemented in core. Except frame loader client really has very little to do with frame loading, and Chrome client has nothing to do with Chrome. Either the browser or the UI, no one really knows why the class is named that way, because it's sort of just a dumping ground for callbacks that want to go somewhere. And what you find is just really incredible call stacks if you look at what goes back and forth between the two parts of the code base. Here's an example. Blink is powered by vsync. So when you append a new DOM node, we schedule a new frame by telling the compositor at the next vsync, please run our lifecycle and our pipeline. This is actually what the call stack looks like in Blink. So first, you'll notice that it goes through scrollable area schedule animation. There's an amazing comment right above this function that says scroll bars should be able to schedule animations. The entire engine is powered by this function. So when this function was added, the only part of the browser apparently that operated by vsync was animated scrolling. You can see how far we've come from there. That's not true anymore, clearly. But the reason we still have this here is because scrollable area is like way out in platform. And the scrolling stuff out in platform needs to be able to schedule animations, and core can use platform, so we left the function way over there. Now what happens, though, when you call this function is it goes first through schedule animation, which is on host window, then to Chrome client, that's sort of dumping ground for stuff. Now Chrome client impl is in web, which calls web view impl, which is also in web, which then goes to this web layer tree view, which is actually implemented in content, which finally calls a method in CC. So it's pretty deep, not too crazy it seems, but still a little silly. Let's look at another example of where this system just doesn't really seem to make any sense. Performance.now. You'd probably assume that that function should be pretty fast and simple, right? I've looked at it in other browsers. It's supposed to return the current time. You think that should be very simple. It's not as simple as you might imagine, though. So performance now goes through JavaScript bindings and calls performance base.now. Then it goes through WTF's, monotonically increasing time. But that function actually does nothing except call a function pointer. Where is that function pointer implemented? Oh, it's actually out in web. What does that function do? It goes through platform, which then goes through web and then out into content. And then content has a method, and that method calls a static method in base, which gets the current time. So every time you call performance.now, which I should hope is like one of the fastest functions in the whole code base, because that's what you do like to measure all your code, you get this really ridiculous virtual call stack to call a static function. Not great. Hopefully we can get rid of that. Let's look at another example here. Here's autofill. Autofill has some really nice stuff. I actually don't have a diagram of it, but one interesting thing that autofill does is autofill is a like render frame observer, I believe, but the methods it does are actually global, and so every time you add a new frame, there's a whole bunch of n-squareds about autofill, because it doesn't really understand. It just keeps newing up autofill controllers, and it's quite exciting. And so this is sort of what autofill looks like. There's like Blink in this boundary, and then autofill's actually split between two places. There's content and components. Way out in Chromium land, they split the codebase up into this directory called components, which contains about 500 other directories that compile in some magical manner that makes the component build work. And it looks sort of like this. So content uses us through this web API, and the web API sort of goes down to core. But it doesn't really work. It turns out if you put a form inside a shadow root, no autofill. It doesn't understand autofill at all. What happened here? What was the failure? Well, so it turns out what the failure here is that the Blink engineers working over here converted the whole code base to understand Shadow DOM. And the code that sits way over there on autofill didn't even get observed. No one knew it even existed. And so it never got updated to understand Shadow DOM. So today, if you put your form inside a shadow root, or use Polymer as an example, autofill just doesn't work. And that's pretty unfortunate. This is actually universally true of almost all features in content. Translate doesn't work with Shadow DOM. Autofill doesn't work with Shadow DOM. The phishing detector doesn't work with Shadow DOM. It turns out if you put your whole page inside a shadow root, the phishing detector says, not phishing you. So that's pretty bad, right? So we don't want to have that going forward. Instead, what we want to do is we want to be on the code reviews that happen for the features that are far away, so that when we say new feature added, let's update the whole code base, that includes all the features that are in content. That includes autofill, that includes Omnibox. Anything that was impacted by a web platform change should also get updated when we update Blink. So let's talk about how we're going to fix this. What are we going to do to fix these problems, these ridiculous call stacks, these crazy client dumping interfaces, these features that get left behind when the web platform evolves? First step, I think we should introduce an API. So we have an API today, except it's way too complicated. It's full of clients and callbacks and like 500 functions, and they get called in some obscure order, and no one really knows how they work. Another example here is Blink had a callback that came out that said first visually non-empty layout. So the key thing there is visually non-empty and layout. Blink, Chromium immediately converts it to first visually non-empty paint. Now this had nothing to do with paint actually, but Chromium thinks it's paint, and then it records an UMA metric that's about paint. Someone in Blink then went and changed the callback to like have better timing, and the UMA metric like jumped. It looked like there was a really bad regression. And it was like, no regression. We moved the callback a little bit. And so this is about trying to make sense of our API. The whole API through the whole stack should make sense. They should have sensible names. Walter Corman, who's, I assume, somewhere in here, recently renamed the interface between CC and Blink also to try to just bring some parity and make our API make sense. So here is what we have and what we're going to introduce. At the top, we're going to have this public API. This public API is implemented through pure virtuals and structures with no behavior. That was sort of the dream of the web API, except that failed really bad because of ridiculous things and historical baggage from a browser that we don't work on anymore. And so instead, we'll introduce this whole stock of pure virtuals, and they will be implemented in core and modules. And what this means for you is that the web layer, the one today that is so painful, actually just moves down into core, or modules as it needs to be. And this removes, I believe Kantara said, over 1,000 abstraction classes. It shrinks the code base a lot. It removes ridiculous plumbing. Now inside core, when you want to call the method to notify the web layer of something, it doesn't go through Chrome client, through FrameLoader client, up, through, and down and around. You just call the method directly. And this removes just incredible amounts of plumbing. And as I said yesterday, when the code base makes sense, our platform makes sense, and our developers are happier. So that's step one. Step two is let's delete a lot of these abstractions. We have so many abstractions here, and a lot of them just don't make sense. So what we're going to do is we're going to take the platform from content, and we're just going to like pick it up and sort of like pull it inside. And instead of having this like big platform abstraction that's actually implemented very far away and sometimes wrong or confusingly, we're going to make our platform actually contain the behavior. And that removes even more abstractions and plumbing, and it gives you the ability to implement a feature much much simpler. But we actually want to remove a lot more abstraction, like that performance-based stuff, which is crazy. So what we're going to do is say platform can just use base directly. WTF can just use base directly. So all the stuff in WTF right now that's duplicating base, we get rid of. All the stuff in platform that converts between base types, we just get rid of that stuff. If you want to call timeTixNow inside WTF, that's what you do. And that whole call stack collapses down to a single function, which is now, and it returns a double. And that makes us identical to other awesome browsers that have a single function that returns now. And this is a huge improvement on the code base. It's a vast simplification. It seems sort of obvious, but now we have this power, so we're going to do that. The next step we're going to take is we're going to switch Blink to expose high-level services instead of low-level services. Right now, we expose web node. That says, here's an individual DOM node. But that's actually a really bad API, because what about Shadow DOM? Oh, I don't know what that is. And you have to learn a lot about the web platform, actually, to be able to use the DOM correctly. And instead, what we want to do is expose high-level services that are built by people that understand the web platform deeply, and then consumed by people that understand browser features and UI features deeply. So instead of saying, here's the DOM, go build autofill, you'll probably figure it out, we'll say, teach us about how autofill works. And then we will expose an API that is optimized and fast from Blink that understands autofill, and the autofill system, the UI, the pop-ups, will consume that API. And they win because their feature works in more cases and faster, and we win because the feature is faster and safer, and we don't have code at a distance that just randomly consumes the web platform. So how will we do this? Well, we'll do this by something that Ojan sent a doc around about called web modules. And web modules are written in C++, but they use an API that's actually generated from the IDL files. The web platform has this really big API surface, but you don't really need all of it. And so what we'll do is we'll whitelist the web platform the good parts. That means you get first child and query selector, but you probably don't get document.all or any other API like document.write that's really terrible. And from this, though, we take the current web node API, which is hand-rolled and quite limited and painful, and we replace it instead with a very high-fidelity code-generated API. As new web platform features are added, you look at them and say, this feature clearly is good because we added it, I hope, and that means that new code gets to use it. It'd be quite unfortunate, actually, if we added a new API and then said, no, we can't use it in our own code base because that feature's bad. Let's try not to do that. But we also get testability from this. And the testability we get is that it's much easier to test our system because it's built on the same platform that everybody else uses, not on backdoors. Today, most of the web layer is lacking tests. I started writing unit tests and found all kinds of fun bugs out there. We sort of just assumed if autofill uses the API, it probably works. That's not a very good assumption. Instead, we will test our APIs. And this is really great, actually, because there's a secret motive here. If you can build autofill on top of the web platform, even if it requires some like minimal backdoors, we've empowered developers. And every time the autofill team says, there's some API missing, can you please add it? That is like instant flag, like, oh, it was missing from Element. Maybe we should expose this to web developers. And so we sort of pull the web along with us as we add APIs to make sure that browser features and platform features align with each other. And that's actually really great for the web. So it's not just that our code base makes sense, but our developers also have a more powerful platform. And here's an example. The service layer will contain everything from autofill to phishing detector. The page serializer, translate, there's some other stuff in there too I'm probably forgetting. Now this might look similar to other layering efforts that you've seen. For example, there's an effort to maybe rewrite the form controls on top of primitives. Now this aligns with those efforts, but it's slightly different because instead of saying let's rebuild the web platform, which has billions of consumers, we're saying let's rebuild the browser features on top of primitives first. And that gives us a really great learning exercise. They have one consumer, that's Chromium, and the Chromium project, which is by extension like Opera and things. But we have direct control over them. So we can help them evolve with us, and we gain a lot of knowledge from this project. And this is sort of what the dependency graph ends up looking like. You have this public API, it's all pure virtual, and then those interfaces are implemented inside services, inside core, inside modules. And those things can sort of like use each other like they are today, and it sort of funnels down to this platform layer. And there's this platform layer that I'll get to, and then we just removed tons and tons of abstraction here. This is much, much simpler than it was before. The next step is to simplify IPC. Today, if you look at what's in content, it's a substantial amount of very simple IPC plumbing. In fact, today, in Blink, you add a new feature that says, I need to go to the browser. What you do is you add at least 3 levels of abstraction in Blink, which you then implement inside content, and it bottoms out in like IPC message struct and send. And we just want to get rid of all that. That's way too painful. It slows us down. And instead, we say, look, platform can just send IPCs. Platform can use Mojo. Platform can use Chromium IPCs. Blink understands IPCs. That's what it does. And we remove even more levels of abstraction. This vastly simplifies the code base. I saw a recent patch that deleted a whole bunch of layers in the middle, and it was like 1,000 lines removed by just using the Mojo API directly instead of trying to plumb it all the way far away and then copying everything, which is just quite silly. Now, if we look at this and then we group the pieces together, what do we get? And you get something that looks like this. Far fewer lines. You end up with a system where there's a public API. The public API is consumed from the outside, and it's sort of IPCs that come into the system. And then those services are then implemented inside the engine. That's the web platform. The services, which are high-level things that we expose, and the system layer. And the system layer is the low-level primitives that implement the web platform. And you end up with actually a very simple system that looks like this, where the IPC comes from the top, and the IPC goes out the bottom, and it's much easier to reason about. If we fill in our boxes, it looks something like this. Autofill exists in the service layer. The web modules API is what it uses. It uses the system layer to use the platform and WTF types, to use Mojo and IPC. The engine layer similarly uses the system layer. And this whole system actually becomes much simpler. And this new platform at the bottom, if we go back, we can see that's the system here, has a bunch of advantages. First, we moved all of content renderer there. That removes copying, it removes many levels of ridiculous call stacks, and it makes the system simpler when you want to add a new feature. Instead of plumbing your stuff far away, you just call into platform. It also adds this new testability layer. This testability layer is actually really great. Right now, we're not very good at sort of testing the system in levels of isolation. Instead, we sort of test the whole system from the top down. And so what happens is you read the Bluetooth test, and the Bluetooth test creates a like mock Bluetooth provider that then plumbs way out, actually very far away, to, I believe, content Blink test runner, which is like partly implemented in components test runner. You don't have to remember this. It's way too complicated. Instead, we want to make that whole system much simpler. So what we do is we say, Bluetooth should look something like this. There's the JavaScript Bluetooth API, and there's the lower level platform Bluetooth API. That is what operations are required to implement a Bluetooth API. Those are the primitives. And so the JS API at the top is something that has promises. It has JavaScript-friendly semantics. It has events and all kinds of things like that. And then there's a lower level system beneath it that is primitives. That's like open a connection, close a connection, read a buffer. And those are much easier to unit test. Most features on the web can actually be boiled down to a set of high-level operations and then a sort of like big fan-out of JavaScript APIs that funnel down into this. And so you have this split here, which is nice. And this split then allows you to test the platform much easier and assert about the IPCs that both come in and go out of the system. It also allows you to mock the underlying implementation of your feature at a place that's close to your feature. Today, to mock the underlying component of Bluetooth, you actually mock something that's very far away. It's way, way out in content. And instead, you will mock something that is just right there, very close to your feature. And you end up with something like this. The platform layer has IPC tests and unit tests. And the web layer up at the top, the engine, has layout tests and web platform tests. There's a new simulation framework that you can use, and IPC tests. And you might say, what are these IPC tests? I've never had to write one of those before. An IPC test is a test where you assert incoming and outgoing IPCs to Blink. And if we get an IPC that we don't expect, we crash. I don't know what happened there. Why did you send me that IPC? And this is actually really great, because it allows you to expect an outgoing IPC and then mock an incoming IPC, and then we can run Blink without having the big multi-process system, without having the big compositing system. You're just expecting outgoing and incoming messages. This is a very common pattern on the web. You mock incoming and outgoing network requests, and we're going to bring that concept to IPCs because they're basically the same thing. So this project is called Blink Onion Soup. And the Onion Soup project's goal is to deliver better abstractions to you, to make you happier writing code, to make it less painful, and hopefully you will forget about the cross-repo code that you had to write in the long-distance paths. This will also empower unit testing. We want to have better and faster unit tests. The average unit test runs in about 1 or 2 milliseconds. At the sort of high end, the average layout test is something like 70 milliseconds. So there's a massive difference there. We can run many thousands more unit tests in parallel awesomely than the proliferation of layout tests. And when you look at our layout tests today, a lot of them are actually just testing engine behavior. There's an internals object and it says something like update style, tell me how many things were updated. And we don't need to do any of that. You don't need to expose the guts of the engine to write your tests anymore. You should be able to write unit tests at the correct layers and write JavaScript tests at the correct layers, and the system will be more reliable. This also will encourage people to use primitives. Because of the architecture of the system, you are encouraged to split your feature into easily testable primitives and high-level web-exposed features, and then split your tests similarly, and we will be able to share our high-level tests with other browsers, like next door at Firefox, and we will be able to take our unit tests and know that the underlying platform is extremely reliable. Now, there's some future projects. You'll notice that I didn't mention some things. For example, what about WTF in base? Well, for now, we're just going to have WTF in platform use base, and that removes lots of abstraction. In the future, what we'll probably do is we'll lift base up, or WTF up, into base and combine them. And then that will have huge advantages. There'll be no more copying, there'll be far fewer boundaries, there's performance and security advantages, both for us and for the greater code base. And that's the second one too. What about using the WTF string? Well, so we're working on that, but for now, let's say, we'll pretend that we're not going to do that just yet, and then at some point, you'll probably come in, and all of a sudden, all of our standard libraries will be combined, and you will just write code way faster. Now, finally, we want to switch IPC to Mojo. Now, there's no mandate that you have to do that right now, but we're going to empower you by bringing Mojo to platform that says you can use Mojo if you want to. Mojo is really easy. It documents your IPC in a beautiful definition file. And so if you want to use Mojo today, you can. And if you can't, please file bugs against the Mojo team. So thank you, BlinkOn. I hope that this was exciting. I hope that you are excited about the repo merge. You're excited about the new capabilities that will be coming to your toolbox when you're writing code. You're hopefully forgetting about those three-sided patches that are a thing of the past. And hopefully someone has questions.
Are we going to be able to access frames of some sort via platform? Because otherwise, lots of modules will not be able to be implemented with the system. Basically, platform is only working fine if you have a singleton behavior, like web Bluetooth or timing, stuff like that. But if you have anything related to a frame, you are stuck.
Yeah, so the question is, how do we deal with frames? And that's actually a really interesting question. What goes in the platform layer and what goes in the engine layer? And that's up to you. You should split your feature in such a way that you have the higher level concepts and the lower level concepts. It does seem that frames are a low level concept. The web is fundamentally a system of frames. But I think the primary difference will be in the future, the platform layer might know about the frame tree, and Chromium will know far less about the frame tree. Right now, Chromium likes to walk the whole frame tree, but that's actually counterproductive because the frame tree has remote frames and local frames, and it's sort of confused. And instead, we will move almost all frame traversal into a single location of higher level operations. So when Chromium wants to ask a question about something from the frame tree, it'll ask us, and there's a single location of frame tree traversal-like operations.
Does that mean we can move WebFrame client to public platform?
Probably. If that makes your code simpler, then probably yes.
That will make a lot of things simpler.
So it seems like we simplify content and we move lots of logic into services. Does it mean that the interface between content and browser will kind of disappear and we'll just have like Blink and Blink implementers?
That's a good observation. What happens to the rest of content when we move most of content renderer into system? Content sort of gets left with the features that are related to sandboxing and multiprocess. The sandboxing and multiprocess concepts are not particularly inherent to the web. They are a feature of the browser that's very important, but web platform features in general don't need to think about whether they're in a particular process or whether they're in a sandbox. At least I hope not. And so we'll leave those features out there. But it's correct that in theory you could consume Blink if you did not care about sandboxing or reliability. So hopefully not. So the question is, what happens to people that are shipping Chrome that is not Chromium, I believe? Right. So what if you're shipping Opera or a set-top box? What happens to those features? For you, it is up to you to help us design the system layer in a way that is modular so that we can turn features off to benefit you. But I think in the past, we sort of pretended that these situations didn't exist. So as an example, you can sort of turn off features out at content, but they still exist inside Blink. Blink is oblivious to the fact that there's other consumers that are not content, and this should actually benefit those consumers. Because now when you're writing code inside Blink, you will be immediately aware of all of the features that are exposed and which features need to be there for what other high-level services. So as an example, if there's features inside Blink that are only for autofill and you ship a not autofill enabled thing, we can cut it out through the whole stack if we think that's important. Where today that's actually not possible because Blink exposes a bunch of random APIs like, does this web node take up space? And we don't realize that its only consumer is actually autofill.
As a follow-up, so we still say that the embedders embed content, not Blink. So we sort of assume that nobody embeds Blink, but embeds content. Is that right?
Yes, so the question is, would you embed Blink or content? Hopefully content. Again, content is sandboxed, multi-process, highly reliable.
Right, and the other question, so this is a round trip for IPCs. Imagine that there's a public API call, I need to do something to with Bluetooth, and it's asynchronous, so I'm expecting a callback, and it hits my system, and on this slide it hits me through the public API. Is that how it's supposed to be? So the callbacks are going to be a part of public API, not necessarily having the direct calls or anything associated with it mentioned there?
Yes, so the question would be, what happens to your feature if there's calls that come in through the top and calls that go out through the bottom? It's up to you to split your feature in a way that makes sense. The public API is purely virtual interfaces. In theory, they could be implemented anywhere in the stack. Ideally, though, the Bluetooth feature would not be a public exposed API surface of Blink, because it's somewhat strange to me to think that the Bluetooth feature in Blink would be consumed by something that is not the web platform.
Something in Blink expects for a callback, which is asynchronous, that went through the browser. So how does the response go?
That would be handled in the system layer. So the system layer can both have incoming and outgoing IPCs.
So IPCs will go from the bottom as well?
That's correct.
All right, thanks.
Yeah.
So on the WTF and base layer and the merger with Chromium, to what extent are we going to be using the types that are used through the rest of Chromium, standard template library and so on? And to what extent are we going to use? You kind of alluded to it. You said maybe one day we'll wake up and everybody will be using WTF, or like we just had a long thread about converting between all these different string types. And is this nightmare going to end, or what's the plan?
Oh God, the horror. Yeah, I certainly hope so. I think it is very unlikely that we are going to switch to the standard library in Blink. As an example, our string type has been optimized to use very little memory. It has optimizations to choose its storage magically based on whether it's Latin 1 or Unicode points, and like there's a bunch of optimizations that went into it. The atomic string optimization is quite big. Instead, what I think is more likely is that we will find compromises between our data types and the base data types, and we will combine the two libraries. And then each project will decide which types they use. So maybe the entire code base will use rstring. Maybe we will say Blink always uses rstring because we have many of them, and some other feature does not always use rstring because it talks to some third-party library that doesn't understand rstring, and it's actually better for them not to. But on the whole, our goal is to find compromises and then simplify this abstraction, because having two totally separate standard libraries is clearly counterproductive.
So for kind of system features that are implemented today using Mojo, one of the major pieces of bookkeeping is kind of starting with a JavaScript promise up at the V8 side, mapping it to a Mojo callback, then mapping it to some like base bind callback and content, keeping track of all those callbacks when your work is done, kind of reversing that flow and doing all the type conversions necessary. So have you given some thought to kind of making that binding of callbacks and structs a little bit simpler as kind of asynchronous calls go out of Blink and then back from the browser?
So the question is, how do we make this Mojo IPC system easier to use, I think?
Yeah, basically.
Sort of what you're asking.
Especially from like the web platform.
Yes, so hopefully by bringing the IPCs in-house, instead of them being out in content, instead of having them, we'll have them inside the system layer, and there we can have conversion functions that convert between WTF strings and Mojo strings and vectors and so on faster and easier. And we can expose APIs up into the engine layer that understand things like promised lifetime in a way that is acceptable to Mojo. Right now there's actually a totally separate abstraction layer in there, the like web string, web vector stuff. And
Right.
those APIs are actually quite painful to use. And so all of that should go away.
Yeah, I basically what I want is that code to be generated for me, right? So I can say this promise maps onto this Mojo IPC, and then magic happens in the middle. Right now I have to write a lot of custom code to do all the mapping.
So that's actually very important. Another thing we're going to do here is we're going to really embrace code generation for all of these layers. So the web modules API is code generated from IDL. The Mojo layer is code generated from the Mojoms. And we can have the Mojom compiler generate stuff that is friendly to our ecosystem. And so if you have suggestions, you should file those bugs. And I believe we're very excited about making Mojoms produce code that is both fast and usable across our whole stack.
Can you talk a bit more about web modules? Like, is it for low-level things, how to interface with the DOM, or is it just everything, we're going to have WebRTC, web module, and everything up to the highest level?
So web modules, to start, if we go back to here, will be about re-implementing browser features in terms of high-level APIs that go out and the DOM APIs that go into the web platform. So if there's a browser feature that wants to use WebRTC, and for some reason it wants to use the JavaScript version of that API, then yes, we would expose WebRTC as a web module API. Just today, that doesn't exist. In fact, today it's mostly related to the frame tree and the DOM. And instead, we will move those features here, and then we will expose a high-level API. So as an example, autofill will expose, give me the forms in the page and their autofill metadata. But autofill no longer has to go crawl the whole document. And in fact, we can optimize this internally. So you'll profile it. You'll say the autofill service is really hot during page load. Instead of implementing it on terms of the JavaScript primitives, let's have the document just track all forms in a map. But right now, we can't do any of that bookkeeping very easily because we just exposed this very rudimentary web node API.
In one of your slides, you had core modules inside of engines, and it looked like core was kind of grayed out. Is that significant, or is this a choice of color here? Is core fading away, or what's the?
Core and modules will not be going away. Right now, core and modules, it's very interesting actually. So core.
So what I wanted to ask is, do you in this master plan see any change in the core module splits, or is it just an internal detail of engine here?
That is an internal detail of engine. And I think that once we have simplified the code base, that we will be able to make better decisions about the core modules split. Right now, I don't believe that we should change that necessarily. I think there's more important things to mess with in the insanity that we've been dealing with. But in the long term, we should probably embrace depth rules as ways of enforcing boundaries and exposing APIs. Right now, modules and core sort of serves as a silly way of forcing dependencies. That's all it really did. It said like web audio can't use the like other thing, and the DOM can't use web audio. Like you can't talk to web audio inside the paint stack because they're in these like separate compilation units. And that's actually been really good for the code base. But trying to shove them all into separate link units is probably not productive long term. And so instead, we will try to have depth rules between the features, and we will have more API boundaries between them and just ownership, and try to solve it at the code level instead of with the linker.
So a pragmatic one. How do we make sure that web layer disappears and we don't end up with yet another layer of abstraction there?
The question is, how do we make sure that we don't make all the same mistakes we made last time?
And double them while having two new layers, like one old and one new.
Right. So that's a really good question. How do we make sure that we don't end up in this really awful intermediary state? Well, first, in theory, we have these long-lived teams now, so we should have a long-term ownership of this project. But also, hopefully, this public API will have a pre-submit rule that says, your thing must be pure virtual, you may not do that. And we didn't have that in the web layer before. And one of the things that made that very complicated was APIs like WebNode. There's hundreds of thousands of nodes in the page, so WebNode needs to be very fast. So we started dumping behavior into the web layer, and because you don't want to make first child virtual. But in this future, because we expose only high-level services, where are all the forms in the page? What is their autofill metadata? Those can all be pure virtual because you go through the API boundary, and then you hit the like hyper-optimized inline code that we have.
The thing I meant was, how do we make sure that the new public API is implemented on top of core node, not the web node, basically?
By code review. I'm going to delete web node. It will cease to be, and you will not have it anymore.
What would it take to be able to implement services in JavaScript rather than C++?
That's a good question. So how could we implement these services in terms of JavaScript? Right now, the primary issues with using JavaScript are that you can't share code pages, and that causes extra memory usage across all the render processes. Right now, there's one implementation of the autofill code, and it is shared between everybody because it's in read-only code pages, and you can't do that in JavaScript. Even with the snapshot stuff, the compiled code is still generated into V8's heap in that process. And so that would need to be solved. There's also not particularly predictable compilation performance right now with using V8 extras. The code is in the snapshot, but when Crankshaft kicks in, that's not predictable at all, and it's still lazy parsed and so on. And so you need very predictable performance from these features, and you need to not have memory proliferation from having all of your features written in JavaScript. But one great thing is that by using IDL-generated web layer, it's much easier to switch your thing to be written in JavaScript or experiment with it, because we're not giving you thousands of backdoors. We're giving you mostly the DOM and like one function to set that like yellow text on the input.
So for services that aren't web exposed, you could share them in context or using but that way you don't have to have a code base per iframe like you would if you're doing V8 extras for a web.
I don't understand how that part of V8 works, but I'm not aware of being able to share generated executable code.
Did you?
Adam. That's a good question. So who calls this public API? This public API is consumed by the UI level features that would remain over there. So autofill is an example of this. Autofill is connected to like some buttons in the browser, and like the details of which buttons are pressed or like the back button and so on is really not a detail of the web platform. So content has the features that are related to like the UI implementation, and then it calls our API to like present dialogues, build views. I'm talking about views in terms of our UI framework, not other kinds of views. And so, because it doesn't seem like we should be using views inside Blink, but someone needs to be using views to present dialogues and other browser-level Chrome. And the code in the browser process will talk to the code in content. And I believe Jochen called this like content browser. as his like browser level features, and Content Browser consumes our high-level API to implement them.
But in the render process.
That's correct.
I think performance is very critical for the IPC, and would currently the performance issue would be a blocking issue for the current transition to the module. And in Android, there's another kind of IPC mechanism named binder supporting in kernel that was approved very successful. Where the Chrome for Android or the Chrome OS use this kind of IPC. Would it be a choice?
So the question is, what about binder? What about the other IPC systems? I'm not an expert in IPC systems. I'll admit the last time I built my own IPC system, it was built on Unix sockets. So I suspect it was pretty slow. So experts in that area are going to make these decisions. My understanding is that while Mojo is slightly slower, Mojo is also more reliable, and that the team that is using Mojo is very open to feedback. So I suspect if you build a benchmark and you show that they need to improve, that they will work on it. I'm not aware of anything in the area using binder, and I don't know why that decision was made. But you should talk to the team that's using Mojo, and you should talk to the Clank team, who I hope some people that work on Clank are here today, and they might be able to explain to you our choice of IPC system.
Do we need to create a wrapper when we use Mojo IPC from oil-bound objects?
So the question is, do you need to create a wrapper to use Mojo from the engine layer, I assume?
Maybe.
So yes, you will need some level of high-level API and low-level API. But because Mojo interfaces are described in Mojam, we should also be able to just fix the Mojam compiler to generate stuff that does not need wrappers anymore, or to generate the wrappers for us. So hopefully writing lots of hand-rolled wrappers will go away. Yes.
So who's working on that? What's the status right now, and what's the time frame for completion?
So the question is, who's working on this? What is your time frame? Are you just up here spouting craziness? So right now, I am working on this. There is a bunch of people in Tokyo that are giving me feedback on how to execute this. This idea is not just some invention of my mind. Kentaro and Tasek both spent a lot of time researching this and identifying advantages of re-architecting the codebase. So hopefully I will get help from the outside. If you want to come work on this and make our codebase simple, then please come help me. It doesn't just benefit my sanity, but it also benefits all the developers around you, because we have fewer levels of abstraction, simpler code, less crazy, fewer bugs, more tests. So time frame would be as soon as you want to come help me.
Will Blink be able to talk to CC?
So can Blink talk to CC? System can talk to CC. The engine cannot talk to CC in this design.
I mean, are we going to get rid of the CC Blink layer?
Yes, the CC Blink layer and the system layer should be smashed together, and many of the call stacks should turn into non-virtual, just member functions. Chris in the back.
Can you use a microphone?
Shout louder, maybe use a microphone.
Sorry, can you pass this down?
So I think you mentioned that there is maybe, I don't know, hundreds or 1,000 interfaces that would go away, something like that?
I'm citing Kentaro's number, but I believe that it is about 1,000 classes.
Okay, so let's say 1,000.
100, not 1,000.
I'm off that
100,
order, Mac.
okay.
There's
So,
100 classes.
like on a scale of like 1 to 10, how hairy do you think will be untangling each of those 100?
That's a good question. How complicated is it going to be to execute this? I suspect the 80% will be easy and 20% will take a while. So to do this in steps, what we do is we take the web layer and we just sort of pick it up and drop it in core, but don't really make any changes. And then instead of being a like web core refactoring team, we file bugs and we go to the paint team and say, you don't need all these crazy abstractions. And you go to the loading team and you say, you don't need all these crazy abstractions. And then they go and sort of rip out the abstractions that make sense and simplify their code as much as possible.
Sounds good.
Are there any more questions? Kanuko.
So I think I keep asking the same similar questions, but so it looks like a platform and WTF are going to use base, but as you know, there's a kind of big threat on Blink dev that allowing using like a base bind and the base callback with a Blink type could be dangerous in terms of threading. And does it make sense to disallow using those clashes for now until we find out a good way to maybe migrate Chromium's callback to another one?
Yeah, that's an excellent point, actually. Base is actually quite large. It's much bigger than WTF. It encompasses just an incredible amount of features. And we probably should have some amount of whitelisting of what features are good to use in Blink at this time. At the same time, the base owners should hopefully be helping us fix base so that we can use it. As an example, I believe Dana, wherever Dana is, over there, is going to fix base callback so that it has similar semantics to WTF callback. And then we will be able to just use base callback and delete ours. And we will implement the thread-safe copying traits thing that allows us to assert about types up in base, and we will tear down the abstractions. But in the short term, yes, it makes sense to not use base callback until that happens. But in the long term, we hope to collaborate to be able to use as much as possible. Anybody else? Everybody excited to go get beer because I'm over time and you're over conferenced? Was BlinkOn great? It was like, yeah.